What's going on, chemists? Today we're going to be doing lab number 8. This particular lab is a gas law lab. I've got my goggles ready and we're ready to go. Now in this particular lab we're going to take magnesium and interact it with hydrochloric acid and produce hydrogen bubbles. The hydrogen bubbles are the most important. The magnesium, once again, needs to be shined up on both sides with steel wool to ensure that the magnesium is as pure as possible. Looks good. Now I'm going to take the mass of this magnesium strip, but in order to get a more precise measurement, I use an analytical balance. An analytical balance measures 3 past the decimal rather than just 2 past the decimal. The piece of magnesium is so small that I needed to get at least 2 significant figures, and so I got 2 past the decimal. Record that in my data table. Now I roll up the piece of magnesium and set it aside, and now I need to prepare the next part of my lab, which is the hydrochloric acid part. This is a eudiometer tube. A eudiometer tube is specifically designed to capture gas as it gets released. Normally, a graduated cylinder counts from bottom to top, but as you can see, the eudiometer tube counts from top down. It's specifically designed, once again, to capture gases, and the gas bubble gets larger from top down. So in this lab, the hydrogen gas will bubble up through the water and be captured at the top of this eudiometer tube. So I first put half of the eudiometer tube and fill it up with just regular old tap water. Next, I grab some hydrochloric acid. Now this is pretty strong acid, but it's going to get diluted down once it mixes with the water. It's the 3 molar acid. So I got about 10 milliliters and I just toss it in there. It's an excess, which means it's not going to run out. The magnesium is going to run out first. Now I add the rest of the eudiometer tube and fill it up with water all the way up to the top, and then I clamp it onto the burette clamp in order to store for later. I add a little bit of extra water here on the top. It needs to be up to the very, very top, and you'll see a little water actually spill over. And that's completely okay. Next, I'm going to prepare this gigantic graduated cylinder. This is where my experiment is going to be carried out. And so I fill it up all the way to the top with water. And then I add a little bit of extra water to get it way, way up to the tippy top. Next, I take my little chunk of magnesium and I drop it into the water and allow it to sink all the way down to the bottom. You'll be able to see it here kind of flashing in the light, making its way all the way to the bottom. Now it's time to perform the experiment. I'm going to mix the magnesium, which is at the bottom of this graduated cylinder, with the acid solution that's mixed together in my eudiometer tube. So what I need to do is put my finger over the top and get that submerged underneath the water in the graduated cylinder and trapped the little magnesium inside the very narrow eudiometer tube at the bottom and allow those two to mix together. Now magnesium and hydrochloric acid are mixing together, and this is what it looks like at the top. The bubbles you see are hydrogen gas being produced. The hydrogen gas is getting trapped at the top, and the bubble, as you can see, is getting larger and larger. This is what we're collecting, and this is what we're analyzing in this lab. The gas bubble continues to grow until all the magnesium has been used up. I mentioned before, magnesium and hydrochloric acid are mixed together. The magnesium is what's going to run out first, which is going to limit the reaction. Here are the results of my 3 trials. You saw the results of the first trial. I took 0.039 grams of magnesium and I dissolved it, and it produced 43.19 milliliters of gas. As you can see, I also collected a temperature and a total pressure for the gas, and what I'm doing here is collecting all the variables that I need in order to do my calculations later. The temperature affects the final numbers, and so does the total pressure. Remember, the total pressure is actually the sum of the pressure of the hydrogen gas inside the tube plus the pressure of the water that it's collected. And so we need to factor in or subtract out the vapor pressure of the water from the total pressure in order to get an accurate reading of pressure. With these numbers, you can use the calculations outlined in the lab report in order to figure out the molar volume of the hydrogen gas and compare it to the known molar volume of the hydrogen gas. And that's the ultimate goal of this lab. Make sure you take a screenshot of this data table because you'll need these numbers to do your calculations. Well, that takes care of this lab. I hope you enjoyed it. Thanks for watching.